We're diving into a tech revolution today, but not talking about slightly better phones or TVs. It's about quantum computing. It's something so different, I think, that it could make our fastest computers look like children's toys. And you're here to understand the basics of it all and the massive potential of this field without, getting lost in the jargon.
And that's key, yeah, because quantum computing isn't just an upgrade. It's a whole new way of thinking about and solving problems.
Right. So it's not just about speed, it's a whole new game. Can you give me an example of a problem that only a quantum computer could tackle?
Absolutely. Imagine trying to design a new drug, perfectly simulating how it interacts with the human body at a molecular level. Classical computers just can't handle that level of complexity, but quantum computers, with their unique capabilities, might.
That's a great example. Okay, so I keep hearing about these qubits and how they're different from the bits in our regular computers. Can you unpack that for me?
Sure. A bit is like a light switch, either on 1 or off 0. A qubit is more like a dimmer switch. It can be on, off, or somewhere in between. That's called superposition. It's like a spinning coin. It's both heads and tails at the same time until it lands.
So if a qubit can be in multiple states at once, does that mean can it do multiple calculations simultaneously?
Exactly. That's what gives quantum computers their potential power. They can explore many possibilities at once, making them exponentially faster for certain types of problems.
And then there's this whole other mind-bending concept of entanglement. It sounds like something out of Star Trek.
It does, doesn't it? Imagine two of those spinning coins, no matter how far apart, always landing on the same side instantly. That's entanglement, this spooky connection between qubits that allows them to coordinate in ways classical physics can't explain.
Okay, I think I'm starting at the basics here. We've got these superpowered qubits with their abilities of superposition and entanglement. But how do they actually impact things like, let's say, cybersecurity?
That's where things get really interesting. Today's encryption relies on complex math problems that are difficult for even most powerful computers to crack. But quantum computers, with their unique approach, could theoretically break those codes much, much faster.
So our online banking, our personal data, everything we think is secure online could be vulnerable. That's a bit scary.
It is a serious concern. But quantum computing itself also offers solutions like quantum key distribution or QKD, which uses quantum principles to create theoretically unbreakable encryption.
So it's a double-edged sword. It can both break our current security and provide a new, potentially unbreakable kind of security. But what about beyond cybersecurity? You mentioned drug discovery. What are some other areas where these qubit superheroes could make a real difference?
Well, one area with immense potential is personalized medicine. Imagine being able to analyze a person's genes and then use a quantum computer to design a drug perfectly tailored to their specific needs.
That sounds like something straight out of a science fiction movie. Are we talking about eliminating diseases altogether?
It's certainly within the realm of possibility. Quantum computers could also help us solve the protein folding problem, which is crucial for understanding diseases like Alzheimer's and potentially finding cures.
This is incredible. It feels like we're on the cusp of a whole new era of scientific discovery, all thanks to these tiny little qubits. But how long until this is all a reality? When will we see these quantum computers doing all these amazing things?
That's the big question, and it's difficult to give a precise timeline. The technology is still in its early stages, but it's advancing rapidly. Some experts believe we're only a few years away from seeing practical applications, while others think it could take a decade or more.
So it's not a question of if, but when. And when it does happen, it sounds like it's going to completely change the world as we know it.
Absolutely, it's not just about faster computers. It's about um, a fundamental shift in how we approach problems
Yeah.
and what becomes possible.
This is just the tip of the iceberg, isn't it? There's so much more to explore about this quantum world and its implications.
There is, and we'll dive deeper. We'll dive deeper into the potential economic and geopolitical impacts of this quantum revolution, and even explore some of the more mind-boggling aspects of quantum mechanics.
Yeah.
Before we jump into those global implications,
Yeah.
I want to circle back to a point you made earlier about personalized medicine. You asked if we're talking about eliminating diseases, and it's important to remember that quantum computing is a tool. It's not a magic wand.
Right, of course, of
Yeah.
course. I got a bit carried away there. But you have to admit, it's pretty exciting to think about the possibilities.
Absolutely, absolutely it is.
Yeah.
But even with incredibly powerful tools, we still need human ingenuity and ethical considerations and a deep understanding of the problems we're trying to solve.
That makes sense. So while eliminating diseases might be a bit of a stretch at this point, what are some more realistic near-term applications in healthcare?
Well, one area where we could see significant progress is in drug discovery. Currently, it takes years and billions of dollars to develop new drugs. Quantum computers could dramatically speed up that process
Hmm.
by simulating the complex interactions between molecules, allowing us to design and test new drugs much more efficiently.
So instead of spending years in the lab, we could run virtual experiments on a quantum computer and get results much, much faster.
Exactly, and not just faster, but potentially more accurate and targeted as well. We could design drugs that are tailored to specific individuals, taking into account their unique genetic makeup and other factors.
That's incredible. It sounds like quantum computing could completely revolutionize the way we approach healthcare. But I know you mentioned other areas where this technology could have a major impact, like the global economy and geopolitics.
Absolutely. We're already seeing a global race to develop quantum computing technology.
Mm.
Countries like the U.S., China, and European nations are investing heavily in research and development, recognizing the strategic importance of this field.
It sounds a bit like the space race of the 20th century. Everyone wants to be the first to plant their flag on the quantum frontier. But what's at stake here? What are the potential economic and geopolitical benefits of being a leader in quantum computing?
Well, for one, there's the potential for economic dominance.
Hmm.
The countries and companies that master this technology first will likely have a significant advantage in industries like finance, material science, and artificial intelligence.
So we're not just talking about scientific bragging rights. We're talking about real economic and political power.
Exactly. Quantum computing could shift the balance of power on a global scale. It could also have significant implications for national security. For example, imagine a country that can break the encryption codes of its adversaries or develop new weapon systems based on quantum technology.
Okay, that's starting to sound a bit less like science fiction and a bit more like, a potential threat. Is there a danger that this technology could fall into the wrong hands?
It's certainly a possibility that we need to consider. Like any powerful technology, quantum computing can be used for good or for ill. It's up to us as a global community to ensure that it's developed and used responsibly.
So we need to be thinking about the ethical implications of this technology right now, even before it's fully realized.
Absolutely, we need to have open and honest conversations about the potential risks and benefits of quantum computing. We need to establish clear guidelines for its development and use, and we need to ensure that everyone has a voice in shaping this quantum future.
You know, we've been talking about all these incredibly complex and serious topics, but I have to admit, part of me still wants to go back to that science fiction kid in me and ask about the really mind-bending stuff, things like time travel, parallel universes. You know, the big
I
questions.
understand those questions are certainly fascinating. And while quantum computing doesn't give us definitive answers, it does provide some intriguing insights.
For example.
Well, consider the concept of quantum teleportation.
Yeah.
While it's not about physically transporting objects like in Star Trek, it does allow for the instantaneous transfer of quantum information
Yeah.
between two entangled particles, regardless of distance.
Okay, so not quite beaming people up, but still pretty amazing. What are the potential applications of this?
Quantum teleportation could be crucial for building a quantum internet, a network that could revolutionize communication and data security.
Hmm.
Imagine a world where information is not only transmitted faster, but also in a way that's virtually unhackable.
A quantum internet. Wow. It feels like we're talking about a future that's straight out of a science fiction novel.
In many ways, we are.
Yeah.
But it's important to remember that this future is being built or is being built right now through the efforts of scientists, engineers, and researchers all over the world.
This is all incredibly exciting, but I have to admit my head is spinning a little bit. What's the one thing you want our listeners to take away from all of this?
I think that the key takeaway is that we are living in a truly remarkable time. We're on the cusp of a technological revolution that has the potential to transform our world in ways we can only begin to imagine. But this revolution also comes with significant challenges and responsibilities.
So what can our listeners do to prepare for this quantum future?
I would say stay curious, stay informed, and stay engaged. Learn about quantum computing. Talk to your friends and family about it, and consider the ethical implications. The future is not predetermined. It's something we create together.
That's a great point. We all have a role to play in shaping this quantum future. And speaking of the future, where do we go from here? We've covered so much ground, but I know there's still more to explore.
There is. In our final segment, we'll delve into some of the more philosophical and even spiritual implications of quantum mechanics.
All right, we've talked about revolutionizing healthcare, potential economic upheaval, even a quantum internet. Now, I'm really curious to explore what quantum mechanics reveals about the universe and our place in it.
Yeah, it's fascinating territory. See, quantum mechanics, it challenges our everyday assumptions about reality.
Hmm.
At the subatomic level, things aren't so clear cut. Particles can be in multiple states at once, and the act of observing them actually influences their behavior.
So what does that mean for our understanding of the world? Does it imply that reality is subjective, that our perception shapes what's real?
Some physicists interpret it that way. It challenges the classical view of an objective observer independent universe.
Hmm.
It suggests that consciousness or the act of observation might play a fundamental role in how reality manifests.
Okay, that's a pretty big departure from what we're what we're taught in school. Are there any practical implications of this, or is it all just theoretical debate?
Well, it has fueled research into things like quantum consciousness,
Hmm.
exploring the possibility that the brain itself utilizes quantum processes for things like memory or decision making.
So our brains might be tiny quantum computers. That's wild. Are we any closer to understanding how that might work?
It's still very early days, but there are experiments exploring how quantum phenomena might be at play in biological systems. It's a controversial area, but definitely pushing the boundaries of our understanding of both the mind and the universe.
This all raises some pretty big questions. If reality is so fluid at the quantum level,
Hmm.
what does that mean for things like free will or destiny?
That's where things get really philosophical. Quantum mechanics introduces an element of randomness and unpredictability, which which some see as supporting the idea of free will. Others argue that even with quantum randomness, there might be underlying patterns or laws we just haven't grasped yet.
It's a lot to wrap your head around. But what I find most fascinating is that through studying these incredibly tiny particles, we're grappling with these huge questions about the nature of existence itself.
Exactly. Quantum mechanics isn't just about building faster computers or unbreakable codes. It's forcing us to rethink our place in the cosmos, to confront the limits of our knowledge, and to embrace the mystery of what we don't yet understand.
So where does this leave us? What's the takeaway for someone listening to all of this for the first time?
I'd say the biggest takeaway is to stay curious. Quantum mechanics shows us that the universe is far stranger and more wondrous than we ever imagined. There's always more to learn, more to discover, and who knows what incredible breakthroughs or mind blowing realizations are waiting for us just around the corner.
I think that's a perfect note to end on. This deep dive has been a whirlwind of information and mind-bending concepts. Thank you for guiding me through it. And to all of you listening, keep questioning, keep exploring, and keep diving deep into the mysteries of the quantum world. Who knows? Maybe one day you'll be the one making the next groundbreaking discovery.